So we have three questions in this video about the math counts state round in the last three questions. Okay, so this is number 28 on the state sprint one. So let's take a look at the question. So region shown is bounded by the arcs of the circle having a radius of 4, having a central angle measure of 60 degrees, and intersecting points of those point of tangency. Okay, and the area of the region can be expressed in this form. We'd like to find those some of these constants. Okay, so just to make sure you understand the question, it's asking us like what we are actually told. There are some circles has a radius of 4, and then these arcs are just some part of those like the basically the arcs, right? Which is the part of the circumference. So if you have something the center around here, so when you connect this point to this intersecting point and this intersecting point, so this is gonna be a sector as area, right? And we are told this is gonna be 60 degrees. And if you do the same thing with the other one, so you will see there is another point somewhere right there. Maybe somewhere right there. Okay. So, and then I can connect these. Okay, but based on my figure, like this doesn't look like 60. Maybe my radius has to be a bit bigger. So to make it a bit nicer looking, so I will take that center point a bit outside. So it will be maybe something right there. Okay, now this angle looks 60. And if you do the same thing with the other guys, so it will be something like this, right? And I hope I will get enough space right there, but if not, that's okay. I can make it another figure. So if I have something like this in my screen, we don't have enough space, but it will be something similar to this one. So what we are given is this is 4 and this is 4. This is 4, this is 4, this is 4, and this is 4. That's my radii. And the angle right here is 60, and this is 60, so that should be 60. It looks like based on my figure, these are like straight lines, but we have to make sure why that's really the case. Okay, since we know this is the intersecting, and these two circles, when you extend like this way and then this way, right? So they will have intersecting point like as tangent points, right? Okay, so which is why if this is the tangent point, when you draw the line, that should be perpendicular to the radii. So, and then if you were to draw this perpendicular, like the tangent line, so the angle will be 90 and the angle will be 90. So which will force this radius and this radius to collinear, which is on the same line. And the same reason with all other sides. So which is why this is going to be collider triangle. And what we want is the region right here. So if you want to find that region, so you know, area of the collider triangle is the s squared times √3/4. I'm telling this because if you are doing a state level problem, so you should really know about this. If you don't, so you can make altitude, you can find the height from that information. But let's see this one. The one side is 8 units. So the area is going to be 8 squared times √3/4, which is going to be 16√3. So the area of the triangle is 16√3, but we just need to subtract those three area of the sectors, and each sector has 60 degrees. If you combine them, you will get 180 degrees, which is basically half of the circle. So combined area is basically 1/2 times pi times radius square, which will give us 8 pi, right? So the 8 pi is the sum of the area. So this region, and this region. So 8 pi is just sum of those 3 a's. Again, this is the general formula for equilateral triangle. So this a and this a is not the same a's. Anyway, so we got the area as 16√3 minus 8 pi. Okay, so then we can just find those a, b, c. So a is 16 B is 3, and C is -8. So if you add those, you will get 11. And that is the final answer. So I hope that makes sense. That there are some other ways you can explore, but I think this is kind of good to do, especially for number 28. But I'm gonna give you another idea, which I will ask you to try and see if you can find another solution. If you take this point and then draw like some tangencies. Let's say you draw this line and you draw this line and you draw this line. Those are the three tangency points. And if you were to find the, let me shade this different color, the area of this region. Okay, and then this is gonna be multiplied by 3 because you have same thing on those as well. So you may find that region by using this part. So because this is a perpendicular and this is a perpendicular, if you were connecting these two, you will get a right triangle and you will get a sector with the 30 degrees central angle. But you can go from there as well, but I'm gonna leave that for you to explore, okay? So that was our first question. So let's move on to the second question, which is number 29 on the test. Okay, so this is a probability problem, and we have a bag contains red and white balls. Okay, and what we are given, if 5 balls are pulled from the bag with replacement, the probability of getting exactly 3 red balls. Okay, so getting exactly 3 red balls is 32 times probable of getting exactly 1 red ball. So, okay, so we don't really know number of red or white balls, but what I'm gonna do, let's say probability of getting red is, I don't know, like say P, and the probability of getting the white is gonna be 1 minus P because the total probability has to be 1. And if you are choosing 5, and if you want exactly 3 red, so you will expecting something like this, red, 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 and then the other 2 should be white. But these could be in any order. So, and then if you are getting only 1 red, so you could have red, white, 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 white. So that is 5 balls now. And the probability of getting this order, this specific order, is the P times P times P, because probability of getting a red was P. So which is why that should give us P to the 3rd power times 1 minus P to the 2nd power. Okay, but again, this is one specific order, so I can rearrange these R's and W's in any order, so that will give us another way of getting 3 R's and 2 W's, which needs to be calculated as well. And then the easiest way to do that, how many ways are in these number, like variable or like letters, you can determine 2 spots for W's, which is basically you just need to choose 2 spaces for W's out of 5 spot, and then last ones, like those 3 left over, will be just going to those remaining one. So that will be done 5 choose 2 ways. So there are 5 choose 2 ways to arrange these letters, and then this is gonna be this one. And we are told this is equal to the 32 times of getting these guys. So choosing 1 R is P, and 4 W's 1 minus P to the 4th power. But again, the same reasoning, we can rearrange those like a few different ways. This R could be in any position. There are 5 different places, or you can just choose one of those 5 spots out of 5, which is 5 choose 1, which is the same as 1. And then we are told this probability times 32 has to be this guy. And then this is the equation we should have. And if you simplify a bit, so you will get 10 for 5 choose 2. And then there's a P, there's a P cube, so we can cancel one of these. So you will get P squared. And then there is a 2nd power, this is the 4th power. If you cancel 2 copies of these, you will get 2nd power of those. So that should give us 1 minus P squared. And then there is 32, and then there is only 1 left over. So 5 choose 1 is 5. Okay, so I can divide by 5, which is 2, divide by 2, divided by 2, which is 16. And now, since this is a perfect square, maybe I can expand it, but let's take a square root. So if I take the square root, so P will be 4 times 1 minus P. And from here, so you get 4P, 5P equals 4. So P will be 4 over 5. And the question was asking what percent of the balls originally in the bag are red ones. So P was the probability of getting like red ones, which is 4/5, which is actually 80%. And we are looking for the percentage of the red ones, which is 80. And that is the number 29. So I hope that makes sense. And the last question is algebra problem. It doesn't look like algebraic problem, but we can make it. So here's what we are gonna do. Like we are gonna look at the numbers. Those are huge numbers. If you don't see anything, you can try multiplying, which is not the point, but if you have no other choices, then you can just go ahead and do that. But look at the numbers carefully. Like this is 52,000 some numbers, but the last numbers are kind of somehow related. So, you know, I can see these two are equal. So I'm going to make a substitution to make it nicer. So 52,683, I'm going to choose this is X. The reason why I'm choosing this is X because this is 60, which is lesser than this. This is 706, which is larger than this. So I'm just choosing, like giving this variable for the middle number to make it a bit evenly distribution. So that will give us X times X minus, this is 60, which is 23 lesser than this guy. So X minus 23. And then this is, I choose 83 as like 52,683 as X. And this is 23 more than this guy. So that could be written X plus 23. And the rest is way simple. If you expand those, you will get X squared. And then this is difference of square. If you do remember, if you don't, just expand them. If you expand those, you are gonna get X squared minus 23 squared by using difference of square. And then if you expand those, X squared, negative times this will be negative X squared, negative times this will be plus 23 squared. These guys will cancel. So you got 23 squared. And if you remember your perfect square, so that looks like your final answer. So for a number like 30, this question wasn't actually too challenging, especially on the state level. Okay, so I hope those 3 questions is helpful and clear for you. I'll see you in the next video.